Okay, we're in section 26 of the notes, and we're going to do the examples. Most of the examples are the same examples that I would give my Math 120 students. So basically, it's a review with an added-on addition of some calculus problems, all right? So I'm going to go to the whiteboard and start doing the problems at the whiteboard. Just give me a second to get this warmed up here. Okay, I'm on the whiteboard. So one problem at a time. Again, the way I do these problems may be different than your Math 120 teachers recommend you do them. Again, you're welcome to do it in a variety of ways. But over here, it says consider the following. So if I were given this problem over here, I'm not going to read the questions yet, but I'm going to, basically look at it and wonder what they want me to do with this or possibly do with this and at the pre-calculus level. So one thing you may want to do is just eliminate the parameter. And that way it makes it more familiar because X is a function of T and Y is a function of T. And that's a little bit unfamiliar at this point. So let's write this down. What will we get? Well, if X, if X is equal to T and Y is equal to T over 7, I can just make a simple substitution. What would we get? Y equals, again, Y is T over 7, but T is X. So I get X over 7. So I would clearly know that this is an equation of a line with slope 1/7 and a y-intercept of 0. So it'd be 0, 0. So I'm going to say fairly easy to graph it out. What does it ask me to do? Graph it. What would you get? A line whose slope is 1/7 that goes through the origin. All right, so that's pretty simple. All right, so let's go to the next question. So eliminate a parameter. Well, we've already done that. And what do we find? Y equals X over 7. Fairly simple. Then they asked me to demand this problem, and the demand's pretty simple. What's the demand going to be? What are the X values in the problem? It's all real numbers. All right, so just all real numbers. All right, fairly simple. All right, let's look at number 2, a little more complicated. Consider the following. And again, what I would do is probably, before I answer the questions, just realize parameters are a little bit unfamiliar to me, make a substitution. So what do you get? Y equals 3 T cubed. Well, what's T? It's X. So what do I get? I get Y equals 3X cubed. Now, granted, I would say that you should know how to graph this guy over here. And, looking at it, I hope you realize that it's a fairly simple Math 119 question now. This is a cubic problem. It's got a y-intercept at 0. After the 0, it's always positive. Below the 0, it's always negative. So maybe something like this over here. And what does that look like? It must look like a cubic function. All right, so let's see what the first question is. And again, this is me trying to understand the question. And I think I got, it says graph it. So let's see what we got. Well, they give a better picture. It's right over here. All right, but my picture is fine. All right, eliminate the parameter. We've done that. We got this over here. What's the demand of that problem? All real numbers. Fairly simple to do. Again, these graphs go on forever and ever. All right, so let's take a look at number 3, a little more complicated. It's got an absolute value in it. Again, my goal over here would be to eliminate the parameter. So I'm looking at it, and what do I notice? I know X is a function of T, and Y is also a function of T. Well, I need to solve one of those equations for T, and I'm going to take Y to do that. I'm trying to eliminate the parameter, by the way. What do you get? Y minus 4 equals T. And I'm going to take this and plug it in up here. And what are you going to get? X equals absolute value. What's T? It's Y minus 4. Now we get minus 1. And what do you get up here? X equals the absolute value of Y minus 5. Now, absolute value is introduced, that's going to college at the 0 level, I think 086 or something. But you start to deal with it more formally when you get to Math 119. But I think I'm ready to do this. It's a little more complicated, though. And I realize absolute values can be complicated. So what I would say, probably looking at it, I would probably get a nice easy number over here. And an easy number for me would be where Y is 5. Because when Y is 5, what would I get? I would get X to be 0. Let me see, 1, 2, 3, 4, 5, right over here. All right. Now what? Well, what do I know about X? I know looking at it, X is the absolute value of something. So the X is always going to be above the 0 or equal to it, right? That's really, you probably know what an absolute value looks like. The next thing I want to do is look at, what's another easy value? I'm going to say when y equals 0. All right, when y equals 0. Now, when y equals 0, what do you get? You would get x equals, and again, I'm just looking for easy values. What would I get? I would get x equals, well, if y is 0, I get x equals minus 5, which is just 5. So that's a pretty easy point to plot down. Again, I'm not saying these are terribly accurate graphs. All right, let's take a look. And I think in Math 119, you remembered, I'll write this over here, the absolute value of x. What does it equal? I'll write this down for you. It's y minus 5 if, this is what you learned in Math 119, if y minus 5 is greater than or equal to 0. We'll do that later. And it's equal to the opposite, which is going to be 5 minus y, if y minus 5 is less than 0. So I'm going to keep going forward. They put an equal sign there. I don't need to do that. This would be y greater than or equal to 5. And this would be 5 minus y if the y is less than 5. Well, what I know about these guys, they're lines. This is a line, y-intercept of 5, and it's got negative slope. Again, negative slope. Slope would be minus 1. And this is a line. What is it? A line where the slope is 1. So I know they're lines. Let's go back over here. And what do I know? If you're above y equals 5, I want to point out what I mean by that. If I'm above y equals 5, I'm over here, I'm above it. What is it? It's an equation of a line, y minus 5, slope of 1. So I'll put that in. Looks sort of like this. That's a slope of 1. Again, doesn't be terribly accurately drawn. And then if it's below the 5, right? It's a line, 5 minus y, it's got negative slope. So like this over here. All right, I got it. All right, let's make sure that they did ask that question, and they did. I'm going to go to the graph. It says figure 79. I'm sorry, figure 79 on page 379. It's right over here. We did pretty good. What's next thing? So eliminate the parameter. I think I did that, and that's right over here. We did that. What's next thing? What's the domain of the problem? Well, what's the domain? It's the x values. The x's are going to be, well, looking at it, what are the x's? Greater than or equal to 0. And that's written over here for you. All right, number 4, a little more complicated. Now, again, they're getting more complicated, but these are exact same questions that I give my Math 120 students when we cover the topic. We're still not at the calculus set. So what I'm going to do over here, well, what I've always done, parametric equation, a little bit unfamiliar to me. So e to the 2t. And then what do you get? You get y equals 2 e to the t. Now, I realize the first thing a lot of students would do is write this in terms of logs. They try to solve for t. I'm not saying that's bad, but that's another unfamiliar topic to most students, logs. So what I'm going to do is just simply write x down as e to the t quantity squared. And then what am I going to do? I notice in the second equation, I see e to the t. So what do I get over here? Right? I'm seeing that. Right? I'm seeing the e to the t over here. So I'm going to take the y divided by 2, and I get et. Then I'm going to take this, pop it back in over here. And what do you get? X equals, well, let's see, what's e to the t? It's y over 2 quantity squared. I've eliminated the parameter. There's a problem with elimination of parameter. You may be confused now. So if I were to solve this, then what would I get? I would get, let's see, 4x equals y squared. Now, where'd you study these things? These are parabolas. And you study parabolas in Math 120, right? What does this look like? Well, this parabola looks like this, right? Fairly simple. We're not going to ask you to focus on things like that or the directrix. We're just going to say that's what that looks like. That's that parabola. Unfortunately, it's not the graph of the parametric. And let's describe that, why that is. If you have x equals e to the 2t, and you have y equals e to the t, what do I know about x? X must be greater than 0. What about y? Y must be greater than 0. So let's go back to our graph. I'm going to refine it this time, and I'm going to put a circle here. you may wonder why that is. Both the x and the y must be greater than 0, so they can't touch it. So that's the graph, all right? Let's go look at our picture, see how we did. I noticed in the picture they don't have the hole down there, but I'm going to put the hole in there for you. So I'm going to say this point is not included. What is that point? 0, 0. And it goes off like this over here. And that goes on forever and ever and ever and ever. All right. So let me just see if we did that. We did the graph of it. It was more complicated. Next is eliminate the parameter. When I eliminate the parameter, what I find at 4x equals y squared. Let's go to that. I'm seeing that right over here. And then the domain of it, well, x is greater than 0. Pretty simple. All right, let's do number 5, a little more complicated. But again, it's really the same things we got in math 119. I mean, it's 120, I mean. So let's write this over on the side. And what do you get? You get x equals 3 plus 4 cosine of t. And I get y equals, let me not lose sight of that, 5 plus 4. Well, looking at it, I think I pretty much know, just looking at it, it's a more complicated question. I know the x is going to lie between these numbers over here. And how do I know that? The cosine bounces back and forth between between 1 and -1. So that means that 4 times that would be bouncing between 4, and 4 plus 3 is 7. That's the most it could be. And then -4, -1. All right. Now, by the way, I'm not going to say it's going to be helpful to you. I'm just saying I know this about that x. What about the y? Well, the y also bounces around. Why is that? Sign goes back and forth between plus or -1. So it's going to be 5 plus 4, which is 9, and 5 minus 4, which is 1. Now, here comes my problem. And I'll be honest with you, I'm not saying it's going to be doable, but I want to eliminate the parameter because these look a little complicated to me. So what I would probably do, and I know what some students might want to do, they want to use arc functions to solve for t. I don't think I want to do that. What I want to do is I want to solve for cosine. So it's going to be x minus 3 over 4 equals cosine of t. Let me write this one. It's going to be y minus 5 over 4 equals sine of t. All right. So what am I going to do now? I'm actually going to square both sides. And what do you get? X minus 3, squared over 16 equals cosine squared t. And what's this going to be? Y minus 5 squared over 16 equals sine squared t. And so this is, why would you do that? Because I know about Pythagorean identities. So I'm going to add these two equations together, and you're going to get x minus 3 squared over 16 plus y minus 5 squared over 16 is equal to cosine squared t plus sine squared t. That's 1. So what do I get? X minus 3 squared over 16. I'm going to multiply both sides by 16, and I should see something really familiar here. What is this thing? An equation of a circle where the center, you learned about circles in Math 100. The center is 3, 5, and its radius is 4. I'm going to look at the better picture, but right now, let me just erase that. Right now, I just want to draw a circle. That's all I'm going to do. Right, I'll look at the better picture later. I know the center, and when you took Math 100, you did, the 4-point technique. What's the center? It's 3, 5. You go up from the center, this is 3. You go down from the center, it's still going to be 3. Now I have to go up by 4. So 5 up 4 would be 9. Now, if I go down 4, 5 down 4 would be 1. Let me do this. I'm moving left and right. The y's are not changing there. We'll look at the better picture later, by the way. And if you're at 3 and you move to the right 4, you'd be at 7. If you're at 3 and you move to the left 4, you'd be at -1. Well, you know what? I want to look at the better picture. And the better picture is over here. So what did I say? Let me take a look. I'm going to pull this over here. And again, part of me going through this over here is kind of teach a skill set of how to, verify what you're doing is correct. So we're looking at a better picture. I'm gonna look at this. Pull this over here a little more. I got a better picture here. All right, I want to see if I got the center right. So let me just point this out to you. They said the center is 3, 5, right? Let's take a look at this. 3, 5. That looks pretty good. We did all right. Then they said this point up here would be 3, 9. Looks pretty good. The point down here would be, well, 3, 1. Looks pretty good. The point over here, we said 7, 5, 5, right? Well, I'm seeing the 5. Yep, 7. Point over here. What point did we say over here? Oh, I said -1, 5. I'm seeing the 5. I'm seeing the -1. So my graph is good. All right. So another thing I want to point out is, looking at this thing over here, did I get the, I'm sorry. Let me just see if I got that right. Yeah. So eliminate the parameter. I think I did this. Hope you remember me doing that. Sorry about that. We got the x -3, y -5, 16. Oh, let's see if they put anything else down there. Sorry about that. I want to read that to you. No, nothing else. Oh, you know what? I did write this down. And I hope it's clear from the graph that we got that. And it's clear from the graph we got this over here as well. All right, pretty important. All right, let's go to the next question. More difficult. And my understanding of this over here, they do get more difficult. And that's where I kind of go to machines to do it. But it says graph the parametric function. And, the first thing I do is get it. I'd look at it. Y is equal to t squared. I'll write to the side for you. And the x is equal to, I forgot, t5 minus 4t cubed. Well, again, what I'm going to do is I'm going to kind of go through it with you, that what I would do. Now, what I do and what you do might be different, but our pictures can't look different. So the first thing I would do is I would know that y is always going to be greater than or equal to 0. I know that much. All right. So I'm going to say, is that important to you? Kind of. So if y is always greater than 0, I know my picture is always going to be up here somewhere. All right. Now let's look at the x's. A little more complicated, but I'm still going to look at it. And what I'm going to do is, what I did in prior courses, factor. And I'm going to say t cubed. And what do you get over here? Well, you would get t squared minus 4. I'm going to continue to factor. And what do you get? T cubed, t plus 2, t minus 2. All right. So what I want to do is I want to take easy points here. And I'm going to say t is 0 is an easy point. And why is that? It's easy to plug in for both the x and the y. What would I get? I would get the point 0, 0 at t equals 0. That's done. What's another easy point? I would say t equals 2 would be easy. Now, if t is equal to 2, the x would be 0, right? How do I know that? Look at this over here. What would the y be? It would be 4. So I get a point over here. That point 0, 4, by the way. This point over here is 0, 0. What's another easy point? T equals minus 2. All right, what would this give us? Well, if I did that, what would you get? Well, the x would be 0 and the y would be 4. I'm back over here. I'm going to do sign analysis because I want to see how this thing is traveling for the x's, right? So the y's are always moving up. How do I know that? It's positive. They're always moving up. All right. Now let's look at the x's. And again, maybe a little sign analysis over here. Let's see if I can do that. Maybe I should clarify what I said by moving up. What I'm saying is moving up, that they're always up here somewhere. That's what I meant by that. I didn't mean their direction is always moving up. I'm just saying they're always up here above the 0. Well, let's do this over here and kind of look at it. And again, it's exhausting. I know that. I got 0. And then what do I get? Plus or minus 2. After the 2, it would always be positive. If I chose, I can be careful here, don't I? If I chose 1, what would I get? Positive, negative. And then what do I get? Let's see, I'm going to take a look at that -1, right? Get negative, positive, negative, positive. And below the -2, what do I get? Like -3, I get negative, 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 negative. All right, so what do I know about the x's? The x's are all over the places. You know, they could be on this side. They could be on this side as well. All right. So I'm going to say for the most part, you know, maybe plotting points at this point. Let me get my eraser out. So what's a nice easy point to take? I'm going to go between here. I'm going to pick one. One for t, by the way. And what do you get for the y? Right. Let's go over it. You get 1, right? That's pretty simple. What do you get for the x? Well, if I pick, you know, the 1, what would I get? I'm expecting to get a negative number. At 1 minus 4, it's -3. So if I plot at that point, again, I know it's difficult. I'm not saying it's easy for you. My eraser out. I'm just ballparking this. What do I get? -3, 1. I'll put this over here. All right, I got a point. Let's take t to be -1. I'm sorry, I said -1, right? What do you get? You get 1 for y. And what do you get for the x? Let's put it in. You get, you know, -1 plus 4, which is 3. I'm getting a sense of symmetry over here. So 3, 1. All right. And it doesn't look that great. All right. So, I'm looking at it, and certainly I'm going to say you could take more and more and more points, but this is where a lot of students struggle. All right. So I'm going to take more points if you're struggling. I'm going to say more importantly, though, I don't know if it's worth all that struggle, but you should be able to take more points. If you do that, I want to go to the better graph. I'm going to go over here. And I'm looking at this graph over here. And I want to point out the points I did get. I got this point here. I got this point here. I got this point here. And I got this point over here. Now, granted, I'm not saying I got the graph, but I did get more points. You could take more and more points. And if you do that, you're eventually going to get a feel for it. But what I'm going to claim over here for a lot of students, that is way too difficult for them to do. All right. So I'm going to say using software is going to have to happen at one point. And you want to learn how to use software. So I'm going to talk about using Sage later and using Grapher. Now, someone's going to say, do I need to use those two applications? No. You can use whatever you're comfortable using, and that's a good deal. But you'll get this graph when you do that. All right. Plotting points is crazy difficult. All right. Crazy difficult. So we got the graph. Graph's right over here for us. Make sure you know how to deal with this. Your graph should look similar to mine. Yeah, it should. All right. We got that. And let's take a look. But visually, number 7 says visually determine the points on the parametric curve in figure 82. Well, I'm back at the same figure where the tangent line doesn't exist. So I'm going to do it visually. So I'm going to say here, it looks like a sharp corner. Doesn't exist there. Over here, I'm going to say it doesn't exist. Why is that? I'm getting vertical tangent lines. All right. So look at the picture. So I'm going to say visually, it looks like it doesn't exist at 0, 0. This is a visual reference on it. And I'm going to put this point over here. And I'm going to say X looks, looking at it, I'm going to say somewhere around 6. Again, this is me ballparking. I'm not saying I'm right. I'm ballparking looking at the picture. I can say 2 point something. I don't know, maybe 2.3. I have no idea. What's over here? I'm going to say, I don't know, it looks about -6 and about 2.3. That's approximate. All right. So visually determine the points of parametric curve in a graph where the tangent doesn't exist. But you know what? I think I got a better technique of doing this. So what I'm going to do is I'm going to do the derivative. All right. So let me just remind you what we're taking a derivative of. I'll write this on the side for you. X is equal to, now we're getting to the calculus part, T5 minus 4t cubed. I'm going to write down dx dt. This is always difficult. It's a polynomial, right? So what do you get? 5t4 minus 12t squared. I'm going to write down what y is. What's y? I can't remember. Oh, it's t squared. That's pretty easy. What's dy dt? It's 2t. All right, got to keep moving. I'll check the key later. I want dy dx. And what's that going to be? Well, it's going to be dy dt over dx dt. And what do you get there? Let's write this down. So what's dy dt? 2t. What's dx dt? 5t4 minus 12t squared. All right. So I want to point that over here. I've got that right over there for you. All right. Now what I want to do is I'm going to go back to points, and I want to put the sharp corner. And the sharp corner is going to occur when the derivative is undefined. Right. When's that derivative undefined? Well, at t equals 0, that derivative is undefined. Let me put this down for you. So dy dx is equal to, let's write this over here, 2t. The bottom, I'm going to factor out a t squared. And what do you get there? You would get 5. Let's see. That'd be t squared, right? Minus 12. Boy, that's tough, huh? Okay. We know there's 3 points along the curve. By the way, I'm going to point out where this derivative is undefined at 0. And why is that? You have a division at 0. Where else is it undefined? At t equals, now there's another place where the derivative becomes 0. It's 5t squared minus 12 equals 0. That's 5t squared equals 12. T squared is 12 fifths. T is going to be plus or minus. The bottom is root 5. I'm going to put root 12 down initially. All right, you can simplify that if you want. I'm just not interested. Actually, only going to write it down as 12 fifths, the root of 12 fifths. This is where a lot of students get totally befuddled. They don't know what to do next. Right. What I'm claiming is we want to get the points. So someone says, how do you get those points? I have to know what x is. What's x? Well, it's t5 minus 4t cubed. And I have to know what y is. And what's y? T squared. So let's just try t equals 0 first. What point would you get? Well, plug it in for x, you get 0. Plug it in for y, you get 0. Was I expecting that? Of course I was. Now let's plug in another point. Root 12 over 5. Well, I got to be honest with you. The y is really easy to do. And what do you get? The y would just be 12 fifths. We'll check it with the key later. And we'll also look at the picture. And what do you get over here? Well, this is more complicated. I got to put this down. So what are you going to get over here? You're going to get 12 fifths to the 1/2 power raised to the 5th power minus 4, 12 fifths to the 1/2 power raised to the 3. And what would that give me? I'll write it down for you. 12 fifths to the 5/2 minus 4 times 12 fifths to the 3/2. All right. What's next one going to be? Well, it looks pretty easy to do. That's minus this over here. I'm going to plug it in. The y is really easy to plug on, and you square that, you get 12 fifths. Oh, the x is more complicated. Let's write this down. So it's going to be, let's write this down, minus and let's see what you get there. You get something a little different, don't you? You get this 4 times 12 fifths to the 3/2 minus 12 fifths to the 5/2. All right. They're tough numbers, though. I'm not saying otherwise. So let's take a look, see how we did. And I want to see if I got the points right. And let's just take a look at the first guy. Did I get this one? I'm looking. I got that there. Did I get this guy? Yep, I got this guy too. I wonder if I got the 0, 0 down over there. Oh, I'm sorry. This one says determine a curve where the tangent is vertical. This is where it's vertical. That's vertical. These are vertical tangents. What do you mean over here, over here? But if I want to approximate those numbers, you see they're approximately what I said they were. Let's go to the next one. Determine the single point in the graph that is two different. Oh, a little different. All right. I want to go back over here. I want to select the problem again. And someone says, why do you do that? I can't remember the problem. So let's put this over here. They said determine the 2 points. I'm going to copy this. I got to change my glasses. I have a tough time with these. Yeah, it's hard to get old. You can't see too well anymore. Got to wear glasses. So let me go back to that question. And it says determine the single point on the graph, that parametric curve that has two different t values, and determine the slope of a tangent line at those two different t values. All right, let's see if we can do that. I'm going to say over this point over here, right? I didn't need to do that, did I? So I got to figure that point out. What is that point? Well, I know the point. The point there is really simple. And we did that a while back, right? But you may not be able to remember doing that. I'm sorry about that. I got to go backwards. I've been doing screwy things lately. All right, let me go back over here. And I'm going to say that's definitely where the curve crosses twice. And where is that going to be at the point? I'll write this one down for you. So it's at the point. This is going to be the x point, y point. That appears to be 0, 4. And when did that occur? Well, if you remember, I think we said, I want to remind you what we did over there. We had x equals. We did this before, but I was reminding what we did. If you remember, I factored this guy, and that would be t cubed t squared minus 4. And that would occur. Did I do that right? Yeah, t is plus or minus 2. Okay. That point occurred when t was plus or minus 2. Let me go through that with you. When t is 2, what point do we get? Let's write this down for you. Well, for the x, you'd get 0. And for the y, you'd get 4. Now, if you took t to be minus 2, what do you get for x? You'd still get 0, and you still get 4 for the y coordinate. Now, what do they want me to do? They wanted me to determine the slope of the tangent line at that point. But this occurs when t is plus or minus 2. So I have to write this down. dy dx at t equals 2. That would be this slope. And I want to do this one too. And that's going to be dy dx at t equals minus 2. And here comes the problem. Did we do the derivative? We did. And it's right over here. I'm not going to do that again, but if you, certainly if you said come by during office hours, I don't mind doing anything twice. Let's put this down for you. And we'll check it in the key later. I'm going to do the top number. What's 2 times 2 is 4. Let's do the bottom number. A little more complicated. It's going to be 5 times, well, 2 to the 4th power 2 times 2 is 4, 8, 16. I'll do the arithmetic later. Minus 12 times 4. Let me see if I can do that. And the way I do arithmetic, the way you do arithmetic may be different. I'm going to divide top and bottom by 4. Sorry. We'll check with the key later. I make mistakes in arithmetic all the time. That's 8. Okay, let's do the other one. Well, what's nice about that one over there, I'm looking back at my derivative. 2 times minus 2 is minus 4. And then what do you get? You get 5 times, that thing would be 5 times 16 now. And then you get minus 12 times 4. Well, I'm going to do the same thing. I'm going to divide by 4. You get minus 1. I'm dividing by 4, by the way. 5 times 4 minus 12. And we'll just give you minus 1/8. All right. So let me repeat this. I think I can remember this occurred at plus or minus 2, and the slopes would be, 1/8 minus 1/8. Yep, t is plus or minus 2. The slopes are plus or minus 1/8. We did all right. All right, let's take a look at this one over here. And again, I really mean that, certainly, graphing can be difficult. I know that, but I'm kind of looking at it. And let me see what it says, graph it. And I just want to talk through it a little tiny bit. And I realize I never enjoyed graphing myself. This is 1 minus t squared. Now, certainly what I know about that, I know the x, looking at it. And again, looking at it, the most it could be is 1. And then what happens? Well, the t starts to pull it towards minus infinity. All right. So, it's got a nice little range for the x's. Now, looking at the y's, and again, I'm not saying it's easy. What's the y going to be? Well, the y is going to be, I'll factor out t5. And that would be what? T squared plus 1. Yeah, I did it right. I want to point out this here is always positive. This thing here goes back and forth between plus or minus. So what's the range discovery here? Well, the y is going to be between infinity and minus infinity. So when I look at the graph of this graph, I want to point out, I kind of know that there's a point over here. Now someone's going to, I don't see that, right? Because I'll be honest with you, this thing gets so small around here, you're not going to see this. But I want to claim that this graph is coming in like this over here. All right, what do I know about the x's? It's always less than or equal to 1. I'm going to get my pen out now, and I'm going to put the point down here. What's this point over here? 1, 0. I want to check that. All right, I want to check it. All right, I'm going to look back at my graph. I want to see if 1, 0 is on there. And I'm going to pick, I'm going to pick t to be 0 now. And what would you get over there? Well, if you did that, you would get x to be 1, and you would get y to be 0. Clearly that point, like we said. All right. So I'm going to say, substitutions, all kind of stuff, really not going to be helping you out much. You can do point plotting. For example, if you took x to be 0, what would t have to be? Plus or minus 1. What would you get for y? Well, let's write this down. T equals 1 would produce x to be 0. And what would you get for y? You get 2. Let's take t to be minus 1. Again, it's what's known as point plotting, easy points, by the way. You're still going to get 0 for x, but now what do you get for y? You get minus 1, which is minus 2. All right. You could take more and more points if you want, but the bottom line is, I think using technology is not such a bad idea. But I did use technology to graph that, by the way. All right. Again, that's sort of my pictures. My machine is much better. All right. Yeah, it says you should be able to do this, but I'm going to say you should also be able to look at a computer to get that as well. So the other one says, and this is, I really mean it. For a lot of students, this is just painfully difficult. All right. So what I want to do is I'm going to look at it. And I'm going to say, wow, second derivative. Dy dx, right? You know what I'm going to do? I'm going to do something different. I know the work they put down over there. I want to do something different. And I know it's tough, but here's the deal. If you've got a picture and someone says, what's the point of having a picture? The point of having a picture is to look at the curve and understand what the second derivative is given to you. It's given to you concavity. So if I were to write this down, just looking at my picture, I'm going to say whoops it. I'm sorry about that. I got to erase that now. I'm going to say it looks concave up here. This region here is concave up. And this region over here is concave down. All right. So it says over here, they use second derivative. Find what the parametric curve given by this will be concave up or concave down. Well, you know, I'm looking at it and I'm starting to see something here, right? So I'm gonna do this without doing the derivative, but we'll also use a derivative too, okay? So I'm gonna say, you know, looking at it, I see this over here. And what's this point again? This point over here is 1, 0. I'm gonna write down x equals, and I'm gonna write down y equals. We'll do the derivative later. I'm going to factor this. Right? That would be t squared plus 1, right? So really I'm wondering is like, I want to get this upper part of it. And that means when is the y positive? So the y would be positive when t is greater than 0. Now, how do I know that? I'm looking at this over here. So it's concave up. For t greater than 0. Where's it concave down? Well, it's when t, this portion over here, is when t is less than 0. Got concave down when t is less than 0. Let's go back over here. Concave up, t greater than 0. Concave down, t less than 0. All right. Let's go through the derivative. It's tough. I know that. Let's put down dy dx. Whew. Let's see. dy dt, 7 t5. I'm sorry, 6. I'm sorry. Plus 5 t4. And what's dx dt minus 2t? I'm going to reduce that. All right, give me 1 second. I gotta respond to a message. right, let me get the second derivative now. I'm sorry about that. I had to do the message there. All right, so let's write this down. d2 dx squared. I always find this difficult to do, to be honest with you. So dx dt, I got to put that on bottom. And dx dt is minus 2t. And then I got to take the derivative. Let me write this down for you. I do have to write this down for you. D dt of dy dx. And that's going to be 7t5 plus 5t cubed over minus 2. Okay. And again, I always find this like I have to think. What do you get on top? You definitely get minus 2. And then you get 35. Let's take a look at that. 35 T4. Whoops, I didn't get the 5 in there, did I? Go backwards. 35 T4 plus 15 T squared. I got to simplify this guy now because it's too difficult to look at. And certainly it's positive. Let me write this down. 35 T4 plus 15 T squared. So negative 5 minutes, we'll put 2 over here. And then times, what's the reciprocal of that, which would be dividing by 2T. So 4T. Let's see if I did that right. Yeah, I did okay. And then when you get over here, 35 T cubed plus 15T over 4. Wow, a lot of work. See if I got the right derivative. 35T cubed, 15T. Yeah, did good. So if someone says, oh my God, I even forgot why you even did that. And by the way, I'd much rather look at the graph. I got the concavity ready. I'm just going to check with the second derivative. So, this is dy, I'm sorry, d2 dx squared. This is going to be, I guess I factor, let me do a factor 5t out. And what do you get over there? This would be 4. That would be 7t squared. Is that right? 5 times 7 is 35 plus 3. Well, you know what? I got it. And I'll put this over here. This is t. T equals 0 right over here. And this is the second derivative being analyzed now. And it only 1 0 in it. Plug in, add that positive. Concave up. If you take a number below t equals 0, like negative number, concave down. And that's what we found out before. We found it was concave up for t greater than 0, and concave down for t less than 0. I got to be honest with you, though. I really think looking at the picture might be more helpful. But again, you should be able to take a first and second derivative. It's not easy, though, especially that second derivative. I always find it difficult to do. All right. All right, this one says graph. There's no way you're going to get this by hand. At least I don't think so. I'd be shocked someone get that by hand. But anyway, I use technology to do that. It would be pure, in my opinion, pure hell to do it by hand. But it's easy to graph out using technologies, and I will discuss that. I will discuss using Sage, and I will discuss using Grapher. Again, I'm not telling you need to use either package, but you need to find some software that you're comfortable with that you can graph out with, including going to Wolfram Alpha. There's nothing wrong with that. Nothing wrong at all. All right. Find an equation, the tangent to the curve. I think I can do it. All right. So find an equation of tangent at the point minus 1, 1. By the way, it sure would be nice to have a picture of it. So what I'm going to do is I'm going to go typically I give you pictures on exams. And someone says, why would you do that? We want to make sure you're looking at good pictures. All right. So I'm going to point out, this is the tangent line, and this is the point they're talking about over here. All right. What's this point over here? Well, that point is going to be minus 1, 1. All right. So I got to get the equation of tangent line, right? By the way, there's really no, points in the graph. And the fact that I'm reading it, I know that point where its tangent is at minus 1, 1. What's the equation of tangent line going to look like though? Y minus 1 equals the slope of the tangent there. Whoops, I didn't mean to do that. Slope of the tangent there times x plus 1. Now, by the way, without doing any calculus at all, I want to do the calculus though. I'm kind of looking at that and, I'm going to say, I'm not sure about it, but I know the slope is positive, right? So I'm not really sure about it. I'm looking at this thing here. This would be called the run, and that would be the rise over there. All right. So I'm looking at that, and I'm going to say, roughly speaking, I'm going to say M tan, roughly speaking, looks about 2 to me. All right, let's go over work. And this is why it's so important that you have some reference before you answer a question. And let's write this down. So what do I want to do? I want to find the derivative. And the derivative I want to find is dy dx. It's going to be tough. So what I got to do? I got to put the dy dt, which is going to be cosine t. That's not so bad. Plus 2 cosine 2t. That's not so bad. What's do the bottom going to be? What's the bottom going to be? Let me see if I did the top right. Cosine t. Yeah, let's do the bottom. Minus sine t minus 2 sine 2t. And I want to find out what dy dx is, but I don't know the t. And that's what I got to figure out. All right. Now, I think you probably have a suspicion where it is, but right now you don't know what the t is for that. So I need to find out what the t is. And this is the question. So what I'm going to do is write this down for you. All right. Let me go back over here. I'm going to go back to my pre-calc skills. I know the x is minus 1. And I know the y is 1. Right, so I know this. Someone says, if you know this, could you figure out the t? If you know this, could you figure out the t? Well, I'll be honest with you. I got some troubles over here, but I got to see if I can do that. Right, I have to see if I can do that. And it could be very difficult to do, but I got a picture to sort of help me out. Right. So what do you mean sort of help you out? I'm looking at the picture and I'm thinking maybe I could get that. Right. Maybe I could get that. Let me take a look at that. I'm looking at that right now. I'm seeing the point minus 1, 1. I'm going to make a stab at it. I'm going to say, let's try something. Let's try easy values. And when would I get a 1 in the problem? And I'm going to say maybe at pi over 2. Well, I'm going to look at this equation here and see if that's true. Right, so what do I get? Let me see if it's true. I don't know. Minus 1 equals cosine of pi over 2 is 0, right? Plus the cosine of pi over 2 times, well, that'd be 2, but pi, that'd be minus 1. That certainly satisfies it. Let me try that in the second equation. 1. What's the sine of pi over 2? 1. What's the sine of pi is 0? This works. So I got it. I actually got it. All right. So I'm going to say at pi over 2, when t is pi over 2, I am going to get the point 1. Let me make sure I said that right. Yeah, 1. Did I do that right? Oh, no, minus 1. 1. Let me make sure this, is this x? Yeah, it is. I'm sorry. I have to read that again. So now I know, t is pi over 2, you get to point minus 1, 1. So I can go back over here. And again, I got a picture to look at. I'm going to put this down now. By the way, there's other values of t that would give that. I'm not saying that's the only one. Erase this over here. Cosine pi over 2 is 0. Minus 2. Oh boy, let's see what we get at the bottom. Minus 1. Minus 2 times 0. So what do you get over there? Minus 2 over minus 1, which is 2. So you know what? My ballpark, looking at it, the 2 looks good. It really does. It's all falling into place. Y minus 1 equals 2, x plus 1. I like that answer, by the way. A lot of students want to write it as y equals. Let me put that down for you. That'd be 2x plus 3 now. Let's look at our key and see how we did. Right over here, we got both answers down and make sure of that. Yep, we did it right. Okay, picture worth 1,000 words. It's going to help you a great deal. How am I going to get pictures for the most part? Basically, if they're simple, I'll do them by hand. When they get more difficult, I'll be using software to do that. All right. And again, I think these are a little bit more difficult to do. All right. Are there other ways to do this problem? There are. We're recommending you try to follow along with what we're doing. I know it's difficult though. Thank you for paying attention.